The topic of today's class is stoichiometry. Stoichiometry is the study of ratios of elements to each other in compounds, ratios of compounds to each other in reactions. And we're going to first turn to the study of ratio of elements to each other in compounds. So, what are some common compounds with ratios of elements? C2H6O is acetone, fingernail polish remover. C9H8O4 is the composition of aspirin. C21H26O8 is prednisone, the wonder drug, the wonder steroid that that makes many symptoms go away. And the first thing you want to know when you make a compound then is what is the ratio of these elements. And the most common elements that you have to look at are carbon, hydrogen, and oxygen. So you make a pure compound. Typically it's a solid. And it's got, let's say, it's composed of just carbon, hydrogen, and oxygen because that's the elements you put together to make it. And you want to find out what the ratio of the carbon to hydrogen to oxygen is. And the way that's done is through combustion analysis. Combustion analysis is, the idea is you start off with a compound, CXHYOZ, and we don't know what the X to Y to Z ratio is. And the best thing to do then is to turn this compound into compounds, react it to compounds we know. And the simplest compounds we know that involve carbon and oxygen, hydrogen, oxygen are certainly CO2, and water. And it turns out that you can pretty much take any compound that's made of carbon, hydrogen, oxygen, burn it in oxygen, and make carbon dioxide and H2O. It's a reaction that we know very well. Let's all just experience it right now. I've eaten a meal, and therefore I've eaten all kinds of sugars and carbohydrates, which are carbon, hydrogen, oxygen compounds. And now I need to react it, and therefore I'm going to need oxygen. And how do I get the oxygen? Put it in chat. How do you get the oxygen? You have the sugar inside you. How do you get the oxygen to it? Yeah, of course. You breathe. You breathe it in. So I breathe it in. And what are the molecules that I breathe out? The molecules you breathe out are carbon dioxide. And anyone who's seen the steam when it's cold, that's the water. So you breathe out the CO2 and H2O, and you're burning it. You're doing this reaction. But we want to do this reaction to identify what the elements are. And so the idea is we're going to find out how much carbon dioxide we make. This is carbon dioxide. We're going to find out how much carbon dioxide we make. And we're going to find out how much water we make. If we find out how much carbon dioxide we make, we can find out how much carbon we had. And if we find out how much water we made, we can find out how much hydrogen in the initial compound. And we're on our way to identifying what the compound is, just the same way that we found out that aspirin was C9H8O4, which is the first step of characterizing what the heck you've made. The first step of knowing the chemical compounds you've made. And it is such an important reaction. Combustion analysis is so important that I should tell you a little bit about how we define the CO2 and H2O. And so the basic idea of the experiment, I'll just make a little schema here, is you take your sample, which is typically a powder. So there's your CX HYOZ. You pass in pure O2, and then you burn. And it's hot, and what's coming out then is CO2 plus H2O, plus I guess some oxygen that didn't react. So that's coming out, it's still hot. And now we need to find out how much CO2 and H2O, and we're going to do two things. We're going to first put some calcium oxide. This is a very typical thing to do. Calcium oxide is a solid, but calcium oxide reacts with CO2. It's a solid. CO2 is a gas, and they react to make CaCO3, calcium carbonate. Which is also a solid. We weigh the gain in the mass gain from CaO, which is a solid, to CaCO3, which is also a solid. We find the weight gain. And that gets us the amount of CO2 added. So now we've got the CO2 that's added, and then we want to find out, we're still passing it through it, we still have coming out, now we have H2O, this whole thing is hot, so the whole thing is hot, so the H2O is still a gas, and O2, and what's a good thing that will absorb a water, and a very common thing we could put is another solid. And this solid will be MgSO4, also a solid, magnesium sulfate. And what reaction does magnesium sulfate do with water? Magnesium sulfate, a solid, plus H2O gas, or just H2O anything. It will pick up 7 of them, and it makes a compound that's called a hydrate. And they're written in a strange way. It's a single compound, but it's written like this. There's a dot right there, and it's used to signify a compound where we can detect 2 other compounds that were used to make it, and it's an old-fashioned thing. MgSO4 7H2O means, put in chat, how many hydrogens are there in this chemical formula? 7H2O. So how many hydrogens is it? Put it in chat. That's right. there are 14 of them. So, and then what is the final gas that's coming outside after this magnesium sulfate has become its hydrate? What's the final compound that's coming out? Just put it in chat. It's the O2, the unreacted O2. And so again, we take the weight gain here, to determine H2O that was created. And by determining the amount of CO2 created, the amount of H2O created, we start getting an idea then of how much carbon and hydrogen there is in the original compound, and we're on our way to characterizing the material.